All right, let's jump right into this explainer and crack open what is basically the ultimate cold case, a 5 billion-year-old cosmic detective story about how our very own planet was created. We look around at our beautiful blue world today, the oceans, the weather, these perfectly balanced ecosystems, and it almost feels like it was custom built just for us. But honestly, getting to this point was a completely chaotic, incredibly improbable journey. So picture this, the edge of the Milky Way galaxy, roughly 5 billion years ago. If you were looking at the exact spot where our solar system sits today, you wouldn't see the sun, you wouldn't see Earth, and you definitely wouldn't see any life. You'd literally just be staring into an empty, pitch-black void. Which really begs the question, right? How do we get from absolutely nothing to all of this?
Starting with the molecular cloud. To solve this mystery, we really have to look at our very first ingredient.
And the scale of this cloud is it's almost incomprehensible. I mean, we're not talking about a fluffy white cloud in the sky here. This was a massive, swirling, dark nebula made entirely of dead star remnants. Dust, silicon, metals, gas, the whole shebang. We are talking 100 light years across. To put that completely mind-bending scale into perspective, that is 6 million times larger than the distance between the Earth and the Sun. This colossal graveyard of exploded stars basically held all the raw materials needed to build a brand new world.
The real hero of this story, though, is gravity. Inside this gigantic cloud, gravity starts pulling these tiny dust particles together. And as they clumped up, they got heavier, which gave them an even stronger gravitational pull. It's a massive chain reaction. Particles are colliding at these incredibly violent speeds, generating just intense, unbelievable amounts of heat and energy right at the center. For millions of years, this core grows larger, it gets hotter, it spins faster, until, bam, it ignites. Our sun is born. But around this newborn star, you still have this giant disk of leftover dust and gas just swirling around.
Salt and the birth of planets. Okay, so we've got our sun, but how exactly did that leftover ring of cosmic dust actually turn into solid planets?
For a long time, that was a huge mystery. But the answer actually came from a completely unexpected place. Fast forward to March 2003, up on the International Space Station. Astronaut Don Pettit was hanging out in microgravity, doing some experiments to see how different materials behaved in space. He literally takes a simple plastic bag, pours in some regular, everyday table salt, and gives it a shake. And what he saw answered a centuries-old cosmic question.
In the microgravity of space, floating particles naturally attract and stick together. It's that simple. Instead of just floating randomly, they generate these tiny static charges and naturally pull toward each other. Just like the salt in Pettit's bag instantly clumped up, those microscopic cosmic dust particles orbiting our young sun began to stick to one another. Those tiny little clumps, those were the literal building blocks of Earth. Once these clumps hit about 1 kilometer across, roughly the size of a mountain, the whole game changes. They start generating serious gravity, acting like massive cosmic vacuum cleaners, just sucking up all the nearby debris. It's a completely chaotic process, and it eventually forms about 20 early planets. But the inner solar system was way too crowded. Their gravitational fields basically pulled them into these epic violent collisions, merging them together until the dust finally settled. And we were left with just a few rocky survivors: Mercury, Venus, Mars, and our Earth.
Solar storms and the magnetic field. So Earth existed, but it was definitely not a paradise. It was essentially a boiling ball of magma facing a lethal existential threat.
The young sun was firing off these deadly solar storms, but Earth's ultimate defense mechanism actually came from deep inside itself, the magnetosphere. Because the early Earth was so unbelievably hot, the whole thing was entirely molten. This allowed the really heavy elements, specifically iron and nickel, to sink straight down into the very center of the planet. As the Earth rotated, this core of liquid metal spun along with it, basically functioning like a giant dynamo. This churning engine of liquid metal generated a phenomenal, massive force field.
And this invisible shield is just staggering in size. On the side facing the sun, it extends out about 370,000 kilometers. I mean, that's basically reaching all the way to where the moon sits today. On the dark side, it trails out for millions of kilometers. This shield is the only reason we're here. It completely blocked the deadly solar radiation that actually stripped away the atmosphere of our neighbor Mars. Without it, life on Earth would be cooked in seconds. Instead, it harmlessly redirects those dangerous solar particles toward our north and south poles, which, as a nice bonus, gives us the stunning light shows we call the auroras.
The Theia collision and the moon. All right, so Earth survived the radiation,
But it was still a chaotic mess of wild weather, no reliable seasons, and, unfortunately, a brand new existential threat was barreling right toward it. We only managed to piece together what happened next thanks to the Apollo missions back in the 1960s. For the longest time, people just assumed the moon was some random rock that got captured by Earth's gravity. But when astronauts brought moon rocks back to the lab, scientists were completely floored. These rocks looked scorched, but more importantly, they shared the exact same, highly specific oxygen isotopes as rocks found right here on Earth. It's essentially a chemical fingerprint. They were fundamentally identical, and that pointed to a seriously mind-blowing, catastrophic origin story. About 4.5 billion years ago, a wandering, Mars-sized planet, literally named Theia, smashes directly into the young Earth. We're talking an apocalyptic collision. Huge chunks of both Earth and Theia get blown out into space, creating this burning ring of molten rock orbiting our planet. Slowly, over thousands of years, gravity works its magic again. The debris clumps together just like the salt in the bag and forms our moon. But the impact did something else, something arguably even more important. The sheer force of the crash knocked Earth completely off its axis, leaving it permanently tilted at a 23.5-degree angle. That single, violent event is why we have the world we know today. That 23.5-degree tilt, that is the sole reason we have changing annual seasons. It drives the monsoon rain cycles that bring us fresh water, and it allows us to grow diverse crops all around the globe. Meanwhile, our new moon started using its gravity to pull at the Earth, creating powerful ocean tides. And without tides, essential marine nutrients would just settle out at the bottom of the ocean, totally stunting the growth of life. But there was just one major problem at this point. Earth had tides, sure, but it didn't actually have any oceans yet.
Jupiter and the mystery of water. This brings us to honestly my favorite part of the cosmic detective case, discovering exactly how a burning ball of magma, spinning in a dry vacuum, suddenly got covered in life-giving water.
For decades, the scientific community was totally stumped by this. Then, in January 2005, NASA decided to literally shoot a bullet at a comet. They launched a probe called Deep Impact, carrying a 350-kilogram solid copper projectile. They navigate this thing 270 million kilometers deep into space to intercept comet Tempel 1 and slam that solid copper block into the comet at a mind-bending 38,000 kilometers per hour. Just incredible.
Spectroscopic analysis of the explosion revealed that comets in the distant asteroid belt are actually filled with water ice. Hiding right beneath the rocky crust of these distant comets were tons and tons of frozen water. So, okay, the water was out there. But how did millions of these icy rocks manage to navigate out of the distant asteroid belt and crash specifically into Earth?
For that, we have the undisputed king of the planets to thank, Jupiter. Jupiter is just incredibly massive, and it orbits right next to the asteroid belt. Its immense gravitational pull started tugging on these icy comets. Normally, they had these stable circular orbits, but Jupiter's gravity warped those circles, stretching them out into long, oval, elliptical shapes. This essentially turned Jupiter into a gigantic cosmic slingshot, firing billions of tons of icy comets directly across Earth's orbital path. When they collided with Earth, the ice melted, eventually filling up the massive oceans we have today.
And we actually have the physical receipts for this exact water delivery. Geologists study these ancient minerals called zircon crystals. Well, zircon physically cannot form without liquid water present. When we date the absolute oldest zircon crystals on Earth using radioactive decay, they clock in at exactly 4 billion years old. This is perfect proof that Earth spent its first 500 million years as a completely dry rock before Jupiter's massive comet bombardment finally delivered the oceans.
So let's take a quick step back and look at what we've uncovered. Through the sheer force of gravity, a cosmic vacuum cleaner effect, a molten iron dynamo, an apocalyptic planetary collision, and the literal cosmic slingshot, we finally have an Earth. It's tilted, so it has seasons. It has a moon to stir the oceans. It has a magnetic shield to protect it from the sun, and it has vast, deep oceans of water. The stage for life is perfectly set. But there is still absolutely zero oxygen in the atmosphere. Nothing could breathe. Which leaves us with the ultimate cliffhanger. In a world of just rock and water, how did the breath of life finally arrive? Well, I think we'll have to save that mystery for our next explainer.